The first thing to do is insulate your project really, really well. Minimize the thermal bridges. Their factory, it looks like this. This is the elements coming off the machine. We get them to site, they've got the slots cut in them, they've got the holes. So we've insulation everywhere. And we've added 90mm stud inside all of those boundary wall panels. We've made sure that there's nowhere where you've got continuous timber that you don't have insulation or multiple layers. So just to introduce our project, we built our own post and beam constructed passive house project in Albert Park, and we moved in last June. So this is obviously our own house. It's the first chance I had to design my own project after practicing for, say, 17 years when we started, about 18 on completion. Over the time of practicing for other people doing all these houses and apartments, I had loads of ideas about what I might do when we got our own project. But of course, they're all theoretical until you get a site and you have a context and you have all of the challenges that you need to deal with on that particular site. And then there's budget. So we ended up buying a site that sort of crossed all my red lines. It had very limited access. It had no rear access. It had no opportunity for a kind of a garage or a shed. It was in a heritage area. And yeah, as you can see, it's a really sort of tight, compromised location. It's 4.85 meters wide. All our access on the project was through the front fence. So we're built right to the boundaries. And we also had stuff like fire rating, overlooking, things like that to deal with. Okay, so I put together a really simple 1-minute video just to introduce passive house and how we can achieve passive house. Essentially, there's 5 principles for passive house, and I'll just let the video play and we'll see those. The first thing to do is insulate your project really, really well, minimize the thermal bridges, and then have good quality double or triple glazing. Make your envelope as close to airtight as possible and have a heat recovery ventilation system. Add renewable energy and add operable shading. And then all of those methods combined will get you a passive house. You can do it in any type of project at any scale, from houses up to large industrial and commercial and public buildings. So I've been working in passive house, probably started about 14 or 15 years ago and certified in 2013. Everything we do now is passive house. It's just a non-negotiable. We think it's the best way to build. And we think the outcomes are the best for the owners and for the developers as well. So if we watch this is a built example of this project in Kyneton that I, again, worked with Rob on the design and construction of this. These clients have moved in just last July. And of course, in Kyneton, you've got that cold weather in the wintertime, and you've got some quite hot weather in summertime. So perfect place to actually see a passive house that's orientated perfectly north and how that works in practice. In wintertime, we want to take as much solar gain into the project as possible to use that to warm our house up. We've got a heat recovery system running all year round, 24 hours a day. In spring and autumn, we want to have about 50% of the solar gain taken in. So we design our windows and our eaves to do that. And in summertime, we want to completely shield out that midday sun and of course the morning and evening sun as well. What's happening with the ventilation system is it's taking in cold air in wintertime from outside, and it's using the warm air inside to actually preheat that and keep that warm air inside the house. So I'll just pause this for a second so we can take a look at how that works. So when you draw through the heat exchanger, it's filtered and you provide fresh filtered air that's been conditioned to every habitable space in the house or in the building. And then in springtime, it's sort of pretty balanced, and then more so in the extremes of summer and winter. In summertime, then you get to actually keep the cool air in the house, use that to pre-cool the hot air you're taking in from outside, and then distribute that around the house. So ours is a passive house plus, which means it actually generates more energy every year than it consumes. So it's carbon positive. It's built in glue laminated timber, and we've tried to reduce our embodied energy in this project, and that's one of the reasons why we use timber on our projects. It's a very simple manual construction. So in their factory, it looks like this. This is the elements coming off the machine. We get them to site. They've got the slots cut in them. They've got the holes. I'll just pause it there for a second. There's two types of joints that we've used throughout the entire project. So David, the builder, organized for the steel plates to be CNC cut, and that they're galvanized. They're simply dropped into the slots, and as I mentioned before, stainless steel dowels are placed in the place of what used to be oak dowels, and they're just hammered through the steel slot and back in through the hole on the other side. And that's the entire structure. There's no glues, there's no other mechanical fixing. Just a number of these dowels or pins are hammered through every one of these plates, and that's how the whole house is connected together.
Post and beam, as the term suggests, is effectively just columns and beams, and they can be of many forms. They don't need to be in a rectilinear system. They can be other forms that provide that kind of appearance using timber. And generally, it's an exposed timber application. That way, you're utilising the material, but also expressing the structure as well. It can be used in, and it's commonly used in commercial application, post and beam, and usually in heavier sections to achieve a fire rating. It has an inherent fire rating resistance based on the bulkiness or the large section sizes that are available, and that's due to the char rate of timber. So, you can have traditional glulam. The middle one is an LVL structure that we've glued up into various sections, and then, you can have heavy loads such as libraries and those kind of structures sitting on the floor surface.
This is how they arrived on site. So this is the largest member in the house, and you can see four people can carry that. We stacked them like this, roughly in their locations where we'll need them. They're all numbered as well, so we know which one is which. But it's a big, big jigsaw puzzle. It's a very tight site, so we had to keep those in locations where we weren't moving them repeatedly, and then keep them dry. So the manual assembly is this. We use this manual forklift just to winch them into position, and then when they're up, we just temporarily brace them, and then we drive home those pins. You can see here they're just about to hammer home those stainless steel pins while it's being held upright. And that's the first couple of columns installed. We were really relieved. Somebody was asking in the questions about the tolerances. We designed and checked and rechecked and that. So that's how we reduced our mistakes on this. There was only one that happened to have been cut slightly back to front or something. So that was the only thing that happened. Just a little bit of human error. But on this project, we didn't have any big problems or any big delays because of all that pre-design checking and coordination that we did. The passive house principles insulation is actually a pretty cheap one, but you've got to make sure it's continuous. And if it's not continuous, then we typically add a second layer to cross that as well. So I'll just show a video of how we achieved two of the principles being insulation and trying to, you can't eliminate thermal bridges, but you try and reduce them and then mitigate them where they exist. So at the slab edge, we have that rebate, and then we've added a screed. We've got continuous insulation on all the boundary wall panels. And if I just pause it there, you can see we're adding this PIR insulation around the screed and around any penetrations that we have as well. And that's the insulation ready for install to the ground floor underneath the screed. Just about to pour at this point, and that's it installed. So we've insulation everywhere. And we've added 90mm stud inside all of those boundary wall panels. We've made sure that there's nowhere where you've got continuous timber that you don't have insulation or multiple layers. And the timber itself gets factored into the U value calculations. With timber being a natural insulator, actually you're allowed to have a certain proportion of timber. So yeah, through the project, we just put as much insulation as possible. To give you some ideas of examples, our screed had R23.5, the boundary walls had R5 insulation, the stud walls had R4, the sloped roofs had R6, and the roof terrace had about R4.5. So a little walkthrough of how the living spaces look at the back of the house. Yeah, so this is just coming in. You can see the portal frames doing as I described. It's creating these sort of subtle zones between the kitchen, living, and dining areas. And you can see brought in as much natural light through a couple of light sources as possible. So we've always tried to achieve dual orientation through it. Um, yeah, we wanted to have all those curves and those warm materials throughout the house as well. I'll just bring this forward a bit and come back in. So yeah, that's the alley clad doors, separating living, dining, dropping the levels down as we move through to the rear of the site so the ceilings get higher. Okay, and then I think my last slide about this project is just a very quick slideshow. It just gives you a brief glimpse into some of the other zones we haven't seen. Yeah, it's more like the laundries, circulation spaces, bedrooms with the cathedral ceiling. We built the bed out of the leftover from the Glulam.